Welcome to part 2 of student handout number 6 about box plots. We're now on the back. It says use your knowledge of box plots to answer the questions below. So here we've got a box plot, and we've got a description of kind of what's going on. Christina conducts a poll to determine the number of colleges high school seniors applied to. She creates a box plot to represent the information. Okay, so number of college applications is what the data pieces are. Okay, so there are some seniors that applied to 0 colleges. So your 0, that's your minimum. Over here is your maximum, and the maximum number that people applied to was 9. The median, your middle number, was 6, so that's the number kind of that falls in the middle of the list. Your lower quartile, remember this is quartile 1, is 4. Quartile 3, that's the median of your upper quartile, if you want to think of it that way, was 8. All right, so I think we've kind of already done the hard work. So now we just have to answer the questions. Determine the range of the number of colleges. Well, remember that range is your biggest minus your smallest number. And that is going to be 9 is your max, minus 0, which is your minimum. So your range is 9. What is the median number of colleges applied to? Well, the median number is this number that falls right here. The median for this data set is 6. What is the interquartile range of the number of college applications? Okay, interquartile range, IQR, is the difference between your upper quartile median, which is Q3, minus your lower quartile median, which is Q1. Q3 was 8, Q1 was 4, so the interquartile range is 4. Okay. Which quartile represents the greatest spread in the data? Okay, remember, the box plot basically splits your data into 4 quartiles. Your first quartile is all of this down to your minimum. Your second quartile is from quartile 1 up to the median. Your third quartile is from the median to Q3. And quartile 4 is from Q3 up to your max. Okay? All right, so you can see distinctly 1, 2, 3, 4 areas. Those are your 4 quartiles. Which quartile represents the greatest spread in the data? Which one is widest or has the biggest range, covers the most space? And that is going to be your first quartile. Okay. Okay, first quartile, second, third, fourth. Okay, and just remember, quartile 1 is that mark from the minimum to here. It's the quartile 1 technically is the median of the bottom half of your data. This marks the median of the top half of your data. But basically, your data can be split into 4 parts. Okay. All right, number 8, describe why quartile 1 is larger than quartile 4. All right. Quartile 1 goes all the way from 0 to 4. And it covers more area, so I know that the data is more spread out. Quartile 1 covers more numbers. and is more spread out. Because quartile 1 goes all the way from a reading of 0 up to 4. Okay. Whereas quartile 4 only goes from 8 up to 9. All right. Quartiles, let's see, what do you observe about quartile 2 and quartile 3? All right. From 4 to 6 and from 6 to 8, that's both 2 and 2. So those two quartiles, quartile 2 and quartile 3, are the same size. Because quartile 2 goes from 4 to 6, so that's a difference of 2. And quartile 3 goes from 6 up to 8, and that's also a difference of 2. Okay? All right, we're hopping down to number 9. Use your knowledge of Use your knowledge of box plots to determine if the statements below are true or false. Okay, so we have a box plot for winter and a box plot for summer, and the numbers are recording average monthly rainfall in inches. Okay, I'm looking and I can see, and I don't know what part of the world this is, but for whatever location this is, generally speaking, I can tell that they're going to get more rain in the summer than they're getting in the winter, okay? Because this box is further this way and the numbers are bigger, that kind of thing. Okay, the range in rainfall in the winter was 12 inches. I don't know, let's see. Here, let me get a ruler. Okay, so what I did is I just took a ruler and lightly drew some vertical lines so that I can more clearly see sort of where some of my numbers fall. Okay, they want to know about the range for winter. Winter, your max looks like it's 15. Your minimum looks like it's 3. So 15 minus 3 does equal 12. The range in rainfall in the winter was 12 inches. That is true. All right, next question. The median rainfall in the summer was 13. Okay, the median, first of all, we need to make sure we're looking at summer. This marks the median, and that looks to be not 13, but it sits at 11, so this is false. For half of the months in the summer, the rainfall was greater than 11 inches. Okay, so for half of the months in the summer, the rainfall was greater. This marks the halfway mark. So half of your data is below the median, half of your data is above the median. For half of the months in the summer, the rainfall was greater than 11 inches. That's the halfway is 11, so that's true. For half of the months in the winter, the rainfall was less than 10 inches. Okay. Your median sits right at 10. Okay. So does half of your data for the winter fall below 10 inches? Yes, it does. So that's true also. Okay. So just summarizing, your box plots split data into 5 critical pieces: the minimum, your first quartile, the median, the third quartile, and the maximum. And you can kind of take the box plot once it's done and see your 4 quartiles. From the minimum up to Q1, that's your first quartile. From Q1 to the median, that's your second quartile. From the median up to Q3, that's your third quartile. And from Q3 up to your max is your fourth quartile. Okay. There's a little bit of confusion because Q1 is your first quartile mark, but that marks where your first quartile ends. This marks where your third quartile ends, that kind of thing, okay? But it helps you make sense of some of the data. And if your box is very squished together, then a lot of your data is concentrated in just a few numbers, that kind of thing.